Our goal here is to find the area of a regular hexagon with a side length equal to 12 inches. We don't always have the units given. They can sometimes make it easier to talk about. Now, it's a hexagon, so I know going in I'm looking at a figure with 6 sides. It's regular, so I know I'm going to have a figure where all the sides are the same length, which is why I only have the one measurement to work with. You'll always get for these problems a single measurement and then how many sides we're talking about. We're mostly going to focus in this unit on the regular figures. Need to start with a sketch. So there's a rough sketch of my hexagon. Doesn't have to be perfect, but enough that I can see what I'm working with. Has a side length of 12. So there's my 12 inches. Now, we also know from what we've talked about, there's the center. I'm going to draw in the apothem. Remember, the apothem is the distance from the center of the polygon to the side. And since it's the distance, it's going to meet at a right angle. Now I'm going to draw in these in order to represent the sides of this triangle. One way to think about this is I've got 6 of these triangles going around the figure. So if I can find the area of one of those triangles, I can then figure out the area of the whole figure. In fact, that's where the formula that we've been using comes from. Now, the formula for the area of a regular hexagon is 1/2 apothem times the perimeter. The perimeter is the number of sides times the length of each of those sides. So you could also think of this as 1/2 apothem times the side times the number of those. And that all works into that formula. In order to get the apothem, I'm going to have to do some extra work. So I'm going to take this triangle right here and pull it out. Now, this angle right here, we call the central angle. And since it represents 1/6 of a full circle, I'm going to take 360 degrees, divide it by 6, and that gives me 60. So that central angle must be 60 degrees. On the triangle I've pulled out, it's half of that, or 30. So I take the 60, take half of that, because I'm only looking at half the triangle. I'm not looking at the other half. I'm just looking at this one shaded part here. Same idea. This whole side is 12 units long. I'm only going to use half of it. So even though the whole thing is 12, I'm just going to use this half over here, which is 6. When I look at this right triangle, I see the kinds of problems we've been practicing in our unit on trig. And I can go ahead and I can say, all right, I can now come up with this apothem over there because I know that the tangent of an angle is going to be equal to the opposite over the adjacent, or in this case, the tangent, 30 degrees, is going to be 6 over A. Now I can go ahead and I can evaluate this. So take the calculator, look up tangent of 30. So tan 30 gives me 0.577, 6 over A. And then I can make it a proportion, cross multiply and divide, and I end up with an apothem equal to 6 divided by 10 point, I'm going to call it 10.4. It's 10.39. You don't want to round too much too early or it will throw other answers off. Now with my apothem, I have everything I need to calculate the area. Most of the work in these problems is right here, building this triangle and solving it for the apothem. So let's kind of recap how we got here. All the way around, all 6 of those triangles was 360 degrees. I'm using 1/6 of it. Thus, 360 divided by 6 gives me 60. That's this angle, the central angle. I only want half of that, so I'm going to take half of 60, which is 30. That then sets up this right triangle here, this shaded right triangle here. 6 on the bottom because it's half of 12. The whole thing is 12 units. I only want half of it. Trig to then find out this apothem. Now I just put everybody into my formula, crank out the final answer. Area is 1/2 the apothem, which is 10.4, times the perimeter, 12 times 6. Remember, the perimeter is the distance, the length of one side times the number of sides, since it's regular. So 12 times 6 puts me at 72. Now, if you're playing with units, remember this is in inches, this is in inches, so my final answer will be in inches squared, or square inches to be more precise. So that times 10.4 times 1/2 gives me a final answer of 374.4 square inches. And that would then be the area of this regular hexagon where one side is 12.